Now, these are some items that you're supposed to have done when you were, I think, in college algebra. Almost everything that's in this section is all algebra. It's called partial fractions. For example, let me show you an integral that we would have worked on before. It would have been x squared plus 4x plus 3 dx. Now, I said before, factoring thing won't do you any good. So here's how we would have approached it before. I would have done this. I break that 3 up into 4 minus 1. That will allow me to complete the square on the first 3 terms. So I get x plus 2 squared minus 1 dx. And then here we've got a variable minus 1. So I would probably look to a secant squared minus 1 will give me a tangent squared. So that might be where we want to look. So I might start with secant of theta equals x plus 2. And then secant theta tangent theta d theta equals dx. Okay, so this is going to equal, so I'll have secant squared theta minus 1. And then the dx piece will be secant theta tangent theta d theta. And now this denominator here is tangent squared. Okay, now I can cancel out a tangent. And I'll end up with secant theta over tangent theta d theta. Secant is 1 over cosine of theta, and tangent is sine of theta over cosine of theta d theta. Well, when you flip everything around and fix it all up, you'll end up with 1 over sine of theta, or just cosecant of theta d theta. And the formula for cosecant is similar to secant. You get negative ln CSC theta plus COT theta, cotangent theta, plus C. And now you're not quite done because you've got to put the x's back. So when you set up a thing like this, as long as we don't know the numbers are positive and negative, we can deal with a regular triangle here and just a right triangle and put our stuff in. If I was in a certain quadrant and knew something, then I would know what to make positive and negative here. But anyways, secant is hypotenuse over adjacent. And then this other side then will be x plus 2 squared minus 1 will be the square root of that. So I need CSC theta. Cosecant is hypotenuse over opposite. So I'll get negative ln. Now, I can write it that way, or the original way that thing was written was x squared plus 4x plus 3. So I'll have x plus 2 all over the square root of x squared plus 4x plus 3. And then cotangent will be adjacent over opposite. So I'll have 1 over square root of x squared plus 4x plus 3 plus c. There's no reason for you to do anything more if you don't want to. What I'm going to do next is just to pretty it up. I'm going to add the x plus 2 plus 1 to get x plus 3 all over the square root of x squared plus 4x plus 3 plus a constant. You can even go so far as, if you think of this as being negative 1 out here, then when you use the property of logarithms and write it to the negative 1 power, it has the ability to turn this upside down. So I'll take the negative out. And there is the answer we get. Well, I'm here to tell you there is a second way to do it. So, a second way to do it. A second way uses partial fractions. And you'll see what those are as I go. So let me start with the original problem again. So I have 1 over x squared plus 4x plus 3 dx. Do you remember I said factoring won't do you any good? Well, now it will. I made one whose the first one, the factoring is pretty easy. So I'll get x plus 3 times x plus 1 dx. Now what if it just so happens that I can break this up in such a way as to have 1 over x plus 3 minus 1 over x plus 1. I'll tell you what I'm going to do. I'm going to put a plus here and a minus here. And I'll put a 1/2 here. Check this out. If I try to make this into one fraction again, the common denominator as x plus 3 times x plus 1, let me prove to you that this is what it equals. 1/2 negative 1 over x plus 3 plus 1 over x plus 1 equals, so I'll do the cross multiplication. So I'll get negative x minus 1 there. So I'll get 1/2 negative x minus 1. And then over here I'll get plus x plus 3 all over x plus 3 times x plus 1. And now the x's will cancel, and I will be left with 1/2 times 2 over x plus 3 times x plus 1. The 2's cancel, and we have the original problem. So it does. It actually breaks up into what we call these partial fractions. But now look how easy it is to integrate this stuff. I'll get 1/2 right here will be negative ln absolute value of x plus 3. And for the other one, I'll get plus ln absolute x plus 1 plus a constant. Now, there's the final answer. But to prove we have the same answer as before, look at my answer here. I'm going to take 1/2 negative ln absolute x plus 3 plus ln absolute x plus 1. I'm going to combine them by using a rule of logarithms that says that I'm going to create this into a division. I'm going to make this into a division problem. 1/2 ln x plus 1 over x plus 3. The negative, of course, goes in the denominator. And then if I want, I can take this 1/2 and bring it up. I think I'm going to leave it right there. This is our answer that we have here. Now, let me go back to the answer I had the other way, this guy right here. Let's compare to, what do we got? ln absolute x plus 3. Okay, so we have ln Is there anything else out there? Nothing. Okay. Now what I'm going to do is I'm going to factor this down here. Well, we already have the factor. I'm going to write it this way. I'm just egregiously ignoring anything to whether it would be positive or negative. And I will end up with this here. We'll make that into that. And then I will have 1/2 ln x plus 3 over x plus 1, which is close, except I have an x plus 3 in the top. Let's see what we have here. Let me make sure this is right. Oh, that was a mistake, wasn't it? Let me go ahead and put this -1 there. That will equal ln x squared plus 4x plus 3 all over x plus 3 which equals ln square root of x plus 3 times x plus 1 all over x plus 3. Cancel, that makes that into a square root, and we have 1/2 ln x plus 1 over x plus 3. Now, let me redo the problem one more time, but show you how I get those numbers that I had to break it down. So this will be the official example 1. We'll start with 1 over x squared plus 4x plus 3 dx, and you're still going to recognize that it factors. And the idea is you want to try to write 1 over x plus 3 times x plus 1. You want to write it as something over x plus 3 plus something over x plus 1. You're almost forcing it. So notice that in this problem, the LCD is x plus 3 times x plus 1. So the first thing I'm going to do is multiply by the LCD. So if I multiply through by the LCD, that means this thing, I'm going to get 1 equals. Now when I take the LCD and multiply it to this, the x plus 3 will cancel, and I'll get a times x plus 1, and then I'll get b times x plus 3. Now to determine what a and b are, you can play this little game. I can literally put in anything I want for x right now. So I'm going to try x equals -1. And that gives me 1 equals a times 0 plus b times 2. In other words, b equals 1/2. And then I can play the next game and allow x to equal -3. And I get 1 equals a times -2 plus b times 0. Or a equals -1/2. Thus, 1 over x plus 3 times x plus 1 equals -1/2 over x plus 3. There's a over x plus 3, a, plus 1/2 over x plus 1. There's b. b was 1/2. And you can probably save yourself a lot of heartache by rewriting it as something like this. 1/2 -1 over x plus 3 plus 1 over x plus 1, and they're all ready to take integrals. So that's how I got my 1/2 and my -1/2. So my next example, example 2, I have 1 over x squared minus 5x plus 4 dx. I forgot my integral. And that factors as 1 over x minus 4 times x minus 1 dx. So I'm going to play the same game I did before. I am going to try to get x minus 4, x minus 1 to be denominators. And I went a little too quick, or I wasn't paying attention here. This is an A. And this is a B. Once again, the LCD is this product. So your LCD equals x minus 4 times x minus 1. So multiply everything through by that. And on the left you'll get a 1. And on the right you'll get an A times x minus 1. And you'll get a B times x minus 4. So now to determine what A and B are, I can start by letting x equal 1. Then I get 1 equals A times 0 plus B times -3. So B equals -1/3. And then we could do x equals 4, back to this equation. and I'll get 1 equals a times 3 plus b times 0, and that tells me that a equals 1/3. And so our partial fractions work down to this. So we have an integral 1 over x minus 4 times x minus 1 dx. That will equal the integral. A was 1/3, and a was over x minus 4. B is negative 1/3, and b was over x minus 1. Personally, what I think I would do now is I would take the 1/3 out front, and that'll give me 1 over x minus 4 minus 1 over x minus 1 dx. And so I'll get 1/3 ln absolute x minus 4 minus 1/3 ln absolute x minus 1 plus c. And if you want to, you can use the rules of logarithms to simplify this up. You get 1/3 ln x minus 4 over x minus 1. Don't forget the absolute values. And there you go. Now so far I've only had a 1 up here. What if we vary this stuff? Let's try another one with something in the numerator. So suppose this time I have 2x plus 3 all over x squared plus 6x plus 8 dx. That factors as 2x plus 3 all over x plus 4 times x plus 2 dx. So I'm playing the same game. I'm going to take 2x plus 3 all over x plus 4 times x plus 2, and that's going to equal a over x plus 4 plus b over x plus 2. LCD equals x plus 4 times x plus 2. So I'll multiply everything through by that, and this time instead of a 1 I'll have a 2x plus 3 equals a times x plus 2 plus b times x plus 4. I'm going to play exactly the same game as before. This time I'll let x equals negative 2. Now don't forget to do it over here too. So negative 4 plus 3, I'll have a negative 1 equals a times 0 plus b times 2. So this tells me that b equals negative 1/2. And then I can play the same game with this equation now, but this time let x equals negative 4. And then this time you'll get 2 times negative 4 is negative 8, plus 3 is negative 5, equals a times negative 2, plus b times 0. So this tells me that a equals 5/2. So what I'm proposing is that 2x plus 3 all over x plus 4 times x plus 1 equals 5/2 over x plus 4. A was over x plus 4, right? Yep. Minus 1/2 over x plus 2. Well, I'm going to do what I typically do, and I'm going to change this to 1/2 5 over x plus 4 minus 1 over x plus 2. I'm going to do this. This is a check to see if my arithmetic worked out correctly. So first thing I'll do is multiply. I'll do the cross multiplication business. So I'll get 5 times x plus 2 minus x plus 4 all over x plus 4 times x plus 2. All right, let's see what happens here. 1/2. 5x minus x will give me a 4x. And then 10 minus 4 will give me a positive 6. And if I multiply through by the 1/2, I will get the 2x plus 3 all over x plus 4 times x plus 2. So that's how it breaks up. Let me go ahead and throw this out of my way. This is just tucked away, letting me know that I actually did my work correctly. So this is the guy here. Right here is the guy we're going to integrate. So I'll put those iterations in there when I do it. 2x plus 3 all over x plus 4 times x plus 1 dx is going to equal 1/2 integral 5 over x plus 4 minus 1 over x plus 1 dx. And now these are really easy to integrate. I have 1/2, well, actually, go ahead. 1/2 times 5 ln absolute x plus 4 minus 1/2 ln absolute x plus 1 plus c. You don't need to do anything more as far as simplifying. Now, something like this, I would never recommend in a million years trying to do the trig substitution stuff. There's going to be so many, you're going to have, like, even if x is like tangent squared, you're going to have tangent squared, 5 tangent. It's going to be so ugly, I don't even know that I'd want to do it. So I would rather do partial fractions with something like this. The first thing you really ought to do is see if there's a u du that can work for us. If I let the denominator be u, for instance, my du is going to be like 6x minus 5, and that's not even close. So u du doesn't feel good. Partial fractions are the only thing that feels good. However, before you can use partial fractions, the numerator must have a degree less than the denominator. So let's make a note of that. So how do I make that happen? Well, the easiest thing to do is to long divide. So if you remember long division, we put this thing on the outside, 3x squared minus 5x minus 2, and on the inside we put the numerator. I'm going to 2x squared plus 5x minus 1. And if I want to make a 5, what I need to do is make a 2 appear under here, a 2x squared. So what I can do to make that happen is I can multiply this by 2/3. Now, if I take 2/3 and multiply it to 3x squared, I'll end up with 2x squared. But I got to continue multiplying it all the way through. Then you're going to get negative 10/3 x. And then you're going to get negative 4/3. Now, one of the things that kills students with this long division is they forget they've got to subtract this line from the first line. It's like the 2x squared minus 2x squared, they go away. But now you're going to have the 5x minus negative 10/3 x. So this is like 15 over 3x plus 10 over 3x. Looks to me like we're going to have 25 over 3x. And the same game down here, negative 1 plus 4/3 will be 1/3. So what does my integral become? If you'll recall, this guy right down here is called the remainder. And this up there is called the quotient. those are the only things that really matter as far as what I'm doing. So my integral that I was working was 2x squared plus 5x minus 1 divided by 3x squared minus 5x minus 2 dx. According to what I've just done here, this is equal to 2/3 plus 25/3 x plus 1/3 divided by 3x squared minus 5x minus 2 dx. Now to make life a little bit easier, I'm going to break these integrals up. So the 2/3, I'm going to break them up. So I'm going to get the integral of 2/3 dx plus, and then for this part, I'm going to take the 1/3 out, and I'll get 25x plus 1 all over 3x squared minus 5x minus 2 dx. Okay, the first integral is really simple. This is just 2/3 x. I'll put my plus c when I'm done with everything. Now the second one, it does happen to factor, at least if I made my notes up correctly. If it does, it's going to be 3x and an x, something like that. And then I know that I need to come up with a 2 from here and here. This times this has to be a -2. So in order, I think, to make a -5x there, I'll put a -2 here and a +1 here, and then I'll quickly do my multiplication to make sure I did it. 3x squared minus 6x minus 5x minus 2. That is correct then. So this portion is done. Let's just work this for a moment and see what happens. Okay, so this is an aside, I guess. This is something I'm doing. In the middle of the problem, we have 25x plus 1 all over 3x plus 1 times x minus 2 equals a over 3x plus 1 plus b over x minus 2. And as before, your LCD is, of course, 3x plus 1 times x minus 2. So multiply everything through by that LCD, and the beauty of that is this just clears out the right hand. It clears out all the fractions. That's one of the beauties of the LCD. 25x plus 1 will equal a times x minus 2 plus b times 3x plus 1. And now I'll play the same games as I did before. I'll start with x equals 2. And so I'll get 51 will equal a times 0 plus, if I plug in x equal 2, I'll get b times 7. So b will equal 51 over 7. And then the next game I can play is I can let x equals -1/3. And that'll give me -25 plus 1 equals, and over here I'll get a times -1/3 minus 2 plus b times 0. Well, let me do some simplifying here. -25 over 3 plus 3 over 3 is -22 over 3. And then here I'll get -7/3, so I'll get a times -7/3. So multiply both sides by 3/7. You get 22 over 7. This is always a convenience too. This usually happens that a and b have the same denominator. Alright, so what was I integrating now? This portion right here. Let's go ahead and handle this integral now. So I have 1/3. The integral was 25x plus 1 all over 3x plus 1 times x minus 2. And I was able to rewrite that, just this portion in here. So bracket it off. A was 22 over 7, and A was over 3x plus 1. Is that true? And then B was over x minus 2, and B was what, 51 over 7? I am going to, just as before, I'm going to take the 1/7 out front, and I'll end up with 1 over 21. So I'll have 22 over 3x minus 1, plus 1, plus 51 over x minus 2 dx. Now what I'll do here is for this, I'll let u equal 3x plus 1, but then du would be 3 dx, so I have to divide by 1. So I have to divide by 3, so I have 1 over 21. So what I'm saying is this part right here will be 22 over 3 times ln 3x plus 1. And over here is just straightforward 51 ln x minus 2 in absolute value plus c. If you want to do more than that, fine. But there's absolutely no reason to do it. You can leave it like that, and your answer's fine. One thing that I forgot here, 2x squared plus 5x minus 1 all over 3x squared minus 5x minus 2 dx. I forgot to actually put the whole answer. Don't forget the first part we had was a 2/3 x. And then I've got all this stuff. I could multiply the 1 over 21 through and probably do some simplifying, but why? I don't really care. Now, I may do some simplifying if I were to go ahead and use this answer in a future problem. All right. Now, so far, all of our factors, if you look at this, what they call linear factors, the degree of each of these was just 1. What happens when some of the factors become higher? So, what was my example in the last one? That was example number 4. Let's try this one. This is sit back for a while and enjoy this ride, because this one is going to take a while. Best you can do, you can try to follow along with me, that's fine. Slow me down, pause me, whatever it is you need to do. But you are supposed to have memorized the formula for the sum of cubes. Remember, that's a 1 cubed, so it actually factors like this. Now, what we have here is, as before, we have a linear factor, but then this thing right here is irreducible, or what you might call prime, whatever it is you want to call it. It's not going to break up. That means I'm stuck with this piece like that. I can't factor it unless I choose to go into imaginary numbers, and nobody wants to go there. So I'm stuck with it. What that means is I have to work 1 over x plus 1 times x squared minus x plus 1 equals a over x plus 1 plus, now this is complicated, so let me explain it. Now for this piece right here, we need fractions that are proper fractions. Proper fractions means that a would just be a number. I wouldn't have a being a first degree or higher polynomial because I need it to be lower than this. In a similar vein, I need my numerator to be degree 1 or less to ensure that I have every possible combination available to me. I'm going to introduce 2 unknown quantities now. But no matter what b and c are, this is still a first degree polynomial, which is 1 less than the polynomial below it. So I'll be able to work with this. And we do exactly the same thing as before. It's just not as much fun. The LCD is x plus 1 times all this stuff. So when I multiply through by the LCD, I'm left with this. A times x squared minus x plus 1. And then we're left with bx plus c times x plus 1. There are so many different ways to proceed at this point. I'm not even sure how I want to do it. But I can tell you this. If I start by letting x equals -1, I can wipe this piece out and leave a by itself. So I'm going to start with that. So I'll get 1 equals a, and I'll have -1 squared minus -1 plus 1. And then I'll get b times -1. I really don't care about that part, but plus c. The important thing is that that's all 0. I really don't care about that. So it looks to me like I have 1 equals 3a, which tells me that a equals 1/3. I've got that locked down. Maybe I'll circle it so I don't forget it. All right, so let me go back to this equation up here. I have 1 equals, a was 1/3. Okay, just to avoid fractions, I'm going to multiply through by 3. And I'll end up with 3 equals x squared minus x plus 1 plus 3bx plus c times x plus 1. Not just start playing some games, picking some other values for x. I'm not going to find anything, at least not real, where this is going to zero out. So here, just start picking things that are of convenience. For example, I might find it convenient to allow x equals 0, because that'll wipe b out, and I'll still be left with a c. So let me do that one. X equals 0, and I'll have 3 equals. So when I put 0 in for this, 0 squared minus 0 plus 1 plus 3 times b times 0 plus c times 0 plus 1. What will I have remaining here? I'll have that 1. I'll have 3c. So I'll subtract 1 and divide by 3, and I'll get c equals 2/3. Okay, so let me rewrite the equation again. This is what I had. I'm going to go back to this equation here. Bring it back. I've got my a and c, and let me plug those in. 3 equals x squared minus x plus 1 plus 3 times bx plus 2/3 times x plus 1. Now what do I try? Well, let's see what I have tried before. I tried x equals -1, x equals 0. I have no advice to offer you here. I guess I'm going to let x equal 1 because after 0, 1 seems to be the next easiest number. So I'll throw it in. 3 equals 1 squared minus 1 plus 1 plus 3 times b times 1 plus 2/3 times 1 plus 1. These you're complete. You can choose whatever you want for these things. 3, let's see what I get here. 1 minus 1, I'll get 1 plus 3. Then I'll have b plus 2/3 times 2. So I am going to subtract 1. So what will this be? 6b plus 2/3. And I'll divide by 6. And this tells me that b equals -1/3. It's quite likely your textbook sets up a series of equations, like 3 equations and 3 unknowns. But you can do that. None of these is going to make things very, very simple for you. So whatever way you end up going with, all the better for you at least. All right, so let's rewrite this problem out. Here's what I have so far. 1 over x cubed plus 1 dx equals, now I have to try to break my things up. Where was a at? Let me come back. So a was over x plus 1, and we found a to be 1/3. So 1/3 over x plus 1. That's going to be easy. Plus And then b was negative 1/3. And then c was what? Where was c at? 2/3. And all that was over x squared minus x plus 1 dx. All right, let me go ahead and break this up. This part won't be hard at all. I'll have 1/3 the integral 1 over x plus 1 dx plus, now over here I'm going to bring the 1/3 in front, and I'll end up with negative x plus 2 all over x squared minus x plus 1 dx. This is very fast to rewrite it as 1/3 the natural log of the absolute value of x plus 1. I'll put a plus c in the end when I get there. Now, you could do a completing the square kind of a game here and try to do tangent squared plus 1, and you get a secant squared. So, like if you were to do 1/2 of this squared, you get plus 1/4, and you take away the 1/4 from the 1 to get a 3/4. But what would happen up here is then I think you would end up here getting something. What x would be? Well, actually, what something like x plus 1/2 would be equal to probably tangent, and then you would have a complicated thing here. You would have like tangent minus something with plus a number. I don't know how good it would be to integrate it. So what I'm going to do is some trickery. Let's write this down. I've got this piece locked in, so I'm not going to do anything with that. This is the piece I'm working on right now. So some trickery is this. I noticed that if I took the derivative of x squared minus x plus 1, the denominator, I would get 2x minus 1. Or, so that's not quite what I want, but I do have an x and I do have a 2. What if I do this? Check this out. I am going to factor out a negative 2. See what I did there? Why would I do that? Because right here I can make it do that kind of stuff. I'll show you what I'm talking about. Let's get this stuff out of the way. It may seem like I did nothing right now, but I'll keep that here and I'll just continue this part. What I would like to have negative x plus 1/2 is what I'm saying. So I can do negative x plus 1/2, but then that would leave me with 3/2. Okay. And then this stuff, of course, I'll just leave it hanging around. Doesn't hurt to rewrite that. Why am I doing this? Well, let's go to the next step then. Okay, now I'm going to break this up into two integrals again. So I'll put my answer here that I have so far. And then what I'm going to do is write this as negative x plus 1/2 all over x squared minus x plus 1 dx. And then I'll bring out the 3/2 there, but don't forget the 1/3 that was out there. So that will become plus 1/2 1 over x squared minus x plus 1 dx. Now I'm going to work this part right here. Like I said, if I let u equal x squared minus x plus 1, then du equals 2x minus 1 dx. But if I divide both sides by negative 2, negative 1/2 du will equal negative x plus 1/2 dx. So, what do we get then? I get my 1/3 ln absolute x plus 1. Then what about this piece here? Well, the negative 1/2 times the 1/3 will be negative 1/6. And then I'll have u, but then I'll have my du up on top. And that one's hanging around until I get to it. Only one thing at a time. Okay, so this part then, that'll be ln of u. And what was u? U was x squared minus x plus 1. So I have 1/3 ln x plus 1 minus 1/6 ln x squared minus x plus 1 plus 1/2 the integral of 1 over x squared minus x plus 1 dx. And now, finally, I'm going to complete a square. So what I'm going to do here then is I will notice that if you take half of negative 1, you get negative 1/2. But then if you square it, you get positive 1/4. So I can suck a positive 1/4 out of that 1 and get x squared minus x plus 1/4 plus 3/4 dx. And then I can factor the first three terms. This is a perfect square. Now, it's at this stage that you could probably do this. I would like to have a 3/4 something squared plus 3/4 because then I'll use an arctan. So what I'll do then is I'll let radical 3 over 2u equal to x minus 1/2. That way when I square it, I will get 3 over 4, and I'll be able to factor that stuff out of them. Take the derivative, I'll get radical 3 over 2 du will equal dx. And so, I'll have to take the 1/2 and multiply it by radical 3 over 2. Let me finally finish. I think we're almost home. So I have 1/2 times radical 3 over 2, and then that will give me 1 over 3/4 u squared plus 3/4. And so I'm going to factor out the 3/4, and it'll flip to become a 4/3. So let me pull the 4/3 out there, and I'll get, this here is radical 3 over 4. Then I'll have 4/3, 1 over u squared plus 1 du. And now we know that that is the arctangent of u. So 1/3 ln absolute x plus 1 minus 1/6 ln x squared minus x plus 1 plus, I'll have a lot of canceling. The 4's will cancel. You can leave this as radical 3 over 3, or you can write it as 1 over radical 3. Doesn't matter to me. This is arctangent of u. I'm so done with this problem is I'll just go back and look and see what u was and throw it in. U equals 2 over radical 3 times that stuff. guess I'll put parentheses around it, plus c. There's a lot of cleaning up that can happen if you want to, but guess what? Once again, I am perfectly happy with that. I've spent enough time on that problem. So I think we've covered pretty much everything except for some basic rules here. So if you had two linear factors, so two linears, so I don't know if you had something like x minus x naught times x minus x1. This is the kind of stuff where you'll want to set up a system like this. If you have some sort of an irreducible quadratic, I don't know if you, whatever you want to call it, minus x plus 1, you still would have had a over x minus x naught plus bx plus c all over x squared minus x plus 1. So you're going to need something like this whenever you have an irreducible quadratic. The only thing that can come up is if you have repeated linear factors or repeated factors that are repeated quadratic factors. So in example 6, repeated linear factors, repeated quadratic factors would be similar. I urge you to read your textbook for those kinds of details. There's so many different this and that's that I can cover, so many combinations that I could really go on forever just on this topic. It's not worth as much effort as I'm putting into it, I'll be honest with you. So now the last thing you might have is something where you have repeated factors. They could be linear or quadratic. Suppose I have something like this. So I have 2x minus 3 over x plus 1 cubed. Well, what I would try to do as far as this is concerned, whenever you have repeated factors, or repeated linear factors here, you want to set up a situation like this. And this will be easy. Once you find your A, B, and C, they'll all just be numbers. So I don't have to worry about any of that kind of stuff. And when you go to figure it out, if you the LCD in this case is x plus 1 cubed. If you multiply it by the LCD, you'll end up with a times x plus 1 squared plus b times x plus 1 plus c. You can start by letting x equals -1 to determine what c is. And so I'll have -5. And then these will all wipe out, and that's what I'll get for c. And then keep doing it again and again. So then I'll have 2x minus 3 equals a times x plus 1 squared plus b times x plus 1. And then c was equal to -5. I'll make my life easier by taking this -5 and, well, adding 5 to both sides. So I get 2x plus 2 equals a times x plus 1 squared plus b times x plus 1. If you ever get a quick one like this, you do it. 2 times x plus 1. I've already talked about when x equals -1, so I'm not going to be dealing with x equals -1 again. What I'm saying is, why not cancel it out like so? I could do it again. Now, with that canceled out, I can allow x to equal -1 again. And on the left, I'll get 2. I'll get a times 0 plus b, and it sure looks like b equals 2. So I will have 2x minus 3. Well, actually, no, I should come back to this. This was independent of anything. 2 times I cancel this out, so I have 2 equals a times x plus 1. B was equal to 2 plus 2. If I subtract the 2, well, I wouldn't want to let x equal -1 here, but I let x equal 0, for instance. 0 equals a, and that's all there is to it. So the 2x minus 3 over x plus 1 cubed equaled b was 2, 2 over x plus 1 squared, and c was -5. And then each of these are really easy to do. Throw an integral sign in front of them. 2x minus 3 all over x plus 1 cubed dx equals 2 times x plus 1 to the negative 2 minus 5 times x plus 1 to the negative 3 dx. If u equals x plus 1, du is simply dx. So I'm going to get negative 2 over x plus 1. And then I'll get plus 5 over 2 times x plus 2 squared. Let me just make sure of that one. I'll get to the negative 2 over negative 2. Those will cancel.